Hello students, welcome to this lecture on arithmetic progression. In this lecture, we'll cover some examples, one sum of first n terms of an AP, and then we'll use exercise 5.3 time per minute. Okay. So in first example here, I've asked how many terms of the AP 24, 21, 18, dot must be taken so that their sum is 8. Okay. So here the first term is equal to 24, and the common difference D 21 minus 24, that is equal to minus 3. Okay, and here we consider the sum of first n terms is n equal to 78, and here we need to find the value of n, and we know that the formula is n. This is equal to number of terms n by 2 times first term a plus n minus 1 times common difference d. So here is n is equal to 78, okay, and a is 24 and d is minus 3. Now if we put these values in this formula, then we'll get 78 is equal to n by 2 times 48 plus n minus 1 times minus 3, that is equal to n by 2 times 51 minus n. Okay, so we get this equation 78, this is equal to n by 2 times 51 minus n. And now if we simplify this equation, then we'll get this quadratic equation 3n square minus 51n plus 156 equal to 0. Okay, that is n square minus 17n plus 52, 0. Actually here we divide this equation by 3. Okay, and we get this quadratic equation n square minus 17n plus 52, this is equal to 0. But if we now factorize this quadratic polynomial n square minus 17n plus 52 by treating the middle terms minus 17n as minus 4n minus 13n. Okay, then we get this quadratic polynomial in left hand side as n by n minus 4 times n minus 13. Okay, and this is equal to 0. So n minus 4 times n minus 13, this is equal to 0. Or n is equal to 4 or 13. So the value of n is equal to 4 or 13. Both of the value n are positive. So both values of n are admissible. So the number of terms is either 4 or 13. So here remarks, in this case the sum of first 4 terms equal to sum of first 13 terms equal to 8. Okay, and in second remarks, two answers are possible because the sum of the terms from 5th 13 will be 0. Okay, and this is because for positive value of a and the negative value of d, so that terms will be positive and some terms negative, and they will cancel out each other. Okay, and we have also discussed this example. Find the sum of the first 1000 positive integers, the sum of first n positive integers. So sum of first 1000 integers, that is equal to 500 500. Okay, and the sum of first n positive integers, this is equal to n into n plus 1 divided by 2. Okay, basically we have discussed in our previous lecture about this example. And we also have studied in our previous lecture about this example. Find the sum of first 24 terms and the list of numbers whose nth term is given by n plus n. So in this example, basically, we first find the terms a1, a2, a3. Okay, and then here the first term a 5 and the common difference d is 2. Okay, so this list of numbers 5, 7, 9, 11, comma dot 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 will form an arithmetic progression, and here the common difference D is 2, and to find S24 we have N is 24 and is 5 and D is 2. And now if we use the formula Sn, this is equal to n by 2 times A plus n minus 1 times D. Therefore S24, this is equal to 24 by 2 times 5 plus 24 minus 1 times 2. And this is equal to 12 into 10 plus 46, that is equal to 672. Okay, so the sum of first 24 terms of the list of numbers 672. Now let us move to next example. So in this example, a manufacturer of TV sets produced 100 sets in the third year and 700 sets in the seventh year. Assuming that the production increases uniformly by a fixed number here. Okay, then we have to find the production in the first year. Then in second, we have to find the production of in the 10th year and the total production in the 7 years. Okay, so let us solve this example. Since the production increases uniformly by a fixed number every year, so the number of TV sets manufactured in first, second, third, and comma dot 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 years will form an arithmetic progression. Okay, so now let us denote the number of TV sets manufactured in the nth year by n, and then A3 is given to us. This is equal to 600, and the seventh term A7, this is equal to 700. Okay, and we know the third term, this is basically A plus 2D. So A3 is 600, so A plus 2D, this is equal to 600. And the seventh term, we know A7, this is equal to A plus 6D. Okay, so A plus 6D, this is equal to 700. And here we get a pair of linear equations. Now we can solve this pair of linear equations by using elimination method or substitution method. Okay, so here solving these equations, we get D is equal to 25 and A is equal to 550. Okay, so therefore the production of TV sets in the first year is 550. And for second one, A10, the 10 term of this AP, A10, this is equal to A plus 90, that is equal to 550 plus 9 into 25, that is equal to 775. So the production of TV sets in the 10th year is 775. Okay, and here now we have to find the total production of TV sets in the first 7 years. Okay, so here basically we have to find the sum of first 7 years production of first 7 years. Okay, so S7, we have to find S7. Okay, and we know that Sn, this is equal to n by 2 times 2a plus n minus 1 times common difference D. Okay, so S7, this is equal to 7 by 2 times 2 into 500 plus 7 minus 1 times 25. Okay, and this is equal to 7 by 2 times 1100 plus 150, this is equal to 435. So thus the total production of TV sets in the first 7 years is 4375. Okay, now here we'll start exercise 5.3. So in first number question, here you have to find the sum of the following APs. So in first one, we have given 2, 7, 12, dot 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 to 10 terms. Okay, so here we have 10 terms, total to 10 terms. So this AP is basically a finite AP. Okay, now here we have given this 2, 7, 12, dot 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 to 10 terms. For this AP, the first term A is 2 and the common difference D is equal to A2 minus A1, that is equal to 7 minus 2, 5. Okay, and number of terms n is 10. Now we know that Sn, this is equal to n by 2 times 2a plus n minus 1 times common difference d. Okay, and here the value of n is equal to 10 and value of the a is 2 and the common difference d is equal to 5. Okay, now if we put these values in Sn, this formula, then we get S10, this is equal to 10 by 2 times 2 times 2 plus 10 minus 1 times 5. And this is equal to 5 times 4 plus 9 into 5, and this is equal to 5 into 49, and this is equal to 245. Okay, so the sum of 10th sum of the production of TV sets in 10th year is equal to 245. Now here we have given this AP 2, 7, 12, dot, 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 10 terms. Okay. So here the sum of these terms, here basically we have given 10 terms. So S10, this is equal to 245. And in second one, here we have given this AP minus 37, minus 33, minus 29, dot, 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 to 12 terms. Okay, so for this AP, A is equal to minus 37, and the common difference D is equal to A2 minus A1, that is equal to minus 33 minus of minus 37, and this is equal to minus 33 plus 37, that is equal to 4. And number of terms n is equal to 12. Number of terms n is equal to 12, and we know that Sn, this is equal to n by 2 times 2a plus n minus 1 times common difference. Okay, so here now if we put the values of a, n and d, then we get the value of S12, that is equal to 12 by 2 times 2 times minus 37 plus 12 minus 1 times 4, and this is equal to 6 times minus 74 plus 11 times 4, and this is equal to 6 times minus 74 plus 44, and this is equal to 6 times minus 30, that is equal to minus 80. Okay, so sum of the terms of this AP, that is S12, this is equal to minus 180. Okay, and for third one we have given 0.6, 1.7, 2.8, dot, 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 to 100 terms. Okay, so for this AP, A is equal to 0.6, common difference D is equal to A2 minus A1, that is equal to 1.7 minus 0.6, that is equal to 1.1, and number of terms n is equal to 100, and we know that Sn, this is equal to n by 2 times a plus n minus 1 times common difference D, and S100, this is equal to 100 by 2 times 0.6 plus 100 minus 1 times 1.1. Okay, and this is equal to 50 times 1.2 plus 99 times 1.1, and this is equal to 50 into 1.2 plus 108.9, and if we calculate it, then we will get this is equal to 50 times 110.1, and this is equal to 5505. Okay, and now for fourth one, in fourth question here we have given this AP 1 by 15, 1 by 12, 1 by 10 to 11 terms. Okay, so for this AP, A is equal to 1 by 15, N is equal to 11, and the common difference D is equal to A2 minus A1, and this is equal to 1 by 12 minus 1 by 15, that is equal to 5 by 5 minus 4 by 60, that is equal to 1 by 60. Okay, so here the common difference is D is equal to 1 by 60, and the value of A is 1 by 15, and the value of N is equal to 11. So S11, this is equal to 11 by 2 times 2 times 1 by 15 plus 11 minus 1 times 1 by 60. And if we simplify this, and then we'll get this is equal to 11 by 2 times 2 by 15 plus 10 by 60. That is equal to 11 by 2 times 2 by 15 plus 1 by 6. This is equal to 11 by 2 times 4 plus 5 divided by 30. And this is equal to 11 by 2 times 9 by 30. This is equal to 33 by 20. So the sum of this sum of the terms of this AP S11, this is equal to 33 divided by 20. Okay, now let us see question number 2. So in this question, find the sums of given below. Okay, so here we have given this series and we have to find sums. So in first one, we have given 7 plus 10 of 1 by 2 plus 14 plus dot 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 plus 84. Okay, so first one for this AP, first term A is 7 and last term L is 84. And the common difference D, this is equal to A2 minus A1, that is equal to 10 of 1 by 2 minus 7. And this is equal to 21 by 2 minus 7, that is equal to 21 minus 14 divided by 2, that is equal to 7 by 2. Okay, so let 84 be the nth term of this AP. Okay, so 84 be the nth term of this AP. Then last term L, this is L is equal to A plus n minus 1 times D, and 84, this is equal to 7 plus n minus 1 times 7 by 2. And it implies 77, this is equal to n minus 1 times 7 by 2, and it implies 22, this is equal to n minus 1, and it implies n is equal to 23. Okay, the value of n is equal to 23. And we know that this formula Sn, this is equal to n by 2 times first term A plus last term L. Okay, so Sn, this is equal to 23 divided by 2 times 7 plus 84, that is equal to 23 into 91 by 2, that is equal to 2093 divided by 2, and it is equal to 1046 of 1 by 2. Okay, now in second one we have given this AP 34 plus 32 plus 30 plus dot 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 plus 10. So for this AP, first term A is 34, the common difference D is A2 minus A1, this is equal to 32 minus 34, that is equal to minus 2. And the last term L, this is equal to 10, and let 10 be the nth term of this AP, and here L is equal to A plus n minus 1 times common difference D. Okay, and here 10 is equal to 34 plus n minus 1 times minus 2, and if we simplify it, then you'll get 12 is equal to n minus 1, that implies n is equal to 13. Okay, so the number of terms is equal to 13, and we know that Sn, this is equal to n by 2 times first term A plus last term L. Okay, so now if we put these values of n, A and L, then we get Sn, this is equal to 13 by 2 times 34 plus 10, and this is equal to 13 into 44 by 2, that is equal to 13 into 22, that is equal to 286. Okay, so sum of the terms of this AP is equal to 286. And now for 3, here we have given this AP minus 5 plus minus 8 plus minus 11 plus dot 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 plus minus 30. Okay, for this AP, first term A is minus 5, last term L is minus 230, and the common difference D is equal to A2 minus A1, this is equal to minus 8, minus of minus 8, 5. Okay, and this is equal to minus 8 plus 5, that is equal to minus 3. So let minus 230 be the nth term of this arithmetic progression. Okay, and L is equal to A plus n minus 1 times common difference D. So now if we put these values of A, N and L, then we get minus 230, this is equal to minus 5 plus n minus 1 times minus 3. So this implies minus 225, this is equal to n minus 1 times minus 3, and it implies 2n minus 1, this is equal to 75, and it implies n is equal to 76. Okay, so number of term of this AP is equal to 76, and sum of first n terms of an AP is n, this is equal to n by 2 times A plus L. We know that. Okay, so now if we put these values of N, A and L, then we get this Sn is equal to 76 by 2 times minus 5 plus minus 230. Okay, and this is equal to 38 times minus 235, and this is equal to minus 8930. Okay, and now let us move to question number 3. in an AP, given to us the first term A is equal to 5, the common difference D is equal to 3, and the innate term AN, this is equal to 50, and here we have to find the value of N and Sn. Okay, so here question number 3, 1, here given that the first term A is equal to 5, D is equal to 3, and N is equal to 50. So as N, this is equal to A plus N minus 1 times D, and therefore 50, this is equal to 5 plus N minus 1 times 3, and it implies 45, this is equal to N minus 1 times 3, and it implies 15, this is equal to N minus 1, equal to N is equal to, it implies N is equal to 16. Okay, so we know that Sn, this is equal to N by 2 times A plus An, and here now S16, this is equal to 16 by 2 times 5 plus 50, that is equal to 8 into 55, that is equal to 440. Okay, in second one we have given the value of A is equal to 7, A13 is equal to 35, and here we have to find the common difference D and the sum of first 13 terms. Okay, so let us see how to solve it. So here given that A is 7, A13 is equal to 35, and we know that An, this is equal to A plus N minus 1 times common difference D. Okay, and here the value of N is equal to 13, so therefore A13, this is equal to A plus 13 minus 1 times common difference D. Okay, and it implies 35, this is equal to 7 plus 12D, and it implies 35 minus 7, this is equal to 12D, and it implies 28 is equal to 12D, and it implies D is equal to 7 by 3. Okay, so the common difference D is equal to 7 by 3, and the sum of first n terms of an AP, we know Sn is equal to n by 2 times A plus An. Okay, S13, this is equal to n by 2 times A plus A13, and we know the value of n, A, and A13. Okay, so now if we put these values of A, A13, and N, then we get this is equal to 13 by 2 times 7 plus 35. And this is equal to 13 times 42 by 2, that is actually equal to 21 times 13. And if we multiply them, then we will get this is equal to 273. Okay, now let us see for the third one. So in third one, we have given the 12th term of this AP, A12, this is equal to 37, and the common difference D is equal to 3, and here we have to find the first term A and the sum of first 12 terms. Okay, so let us solve this problem. So given that A12, this is equal to 37, and the common difference D, this is equal to 3, and as we know An, this is equal to A plus N minus 1 times common difference D, and it implies A12, this is equal to A plus 12 minus 1 times 3, and it implies 37, this is equal to A plus 33, and it implies A is equal to 4. Okay, so A is equal to 4, that is the first term of this AP is equal to 4. And now we know that the sum of first n terms of an AP is n, this is equal to n by 2 times A plus An. Okay, so now we need to find S12. So S12, this is equal to 12 by 2 times first term, that is 4, and the last term, the nth term, that is 37. Okay, so S12, this is equal to 12 by 2 times 4 plus 37, that is equal to 6 times 41, and this implies the sum of 12 terms, that is S12, is equal to 246. Okay, now let us see fourth one. So in fourth one, we have given the third term of an AP A3 is equal to 15, and the sum of first 10 terms is equal to 125, and we need to find the common difference D and the 10th term of this AP. Okay, so let us solve this problem. So here given that A3 is equal to 15, S10 this is equal to 125, and as we know the innate terms of an AP AN is equal to first term A plus n minus 1 times common difference D. Okay, so now here we have given the third term of this AP, that is equal to 15. So A3 this is equal to A plus 3 minus 1 times common difference D. Okay, and it implies 15 this is equal to A plus 2D, and naming this equation number 1, and we know this formula is n this is equal to n by 2 times A plus n minus 1 times common difference D. Okay, S10 this is equal to 10 by 2 times 2A plus n minus 1 times D, and it implies 125 this is equal to 5 times 2A plus 9D, and it implies 25 is equal to 2A plus 9D. Okay, so we get this linear equation, and one multiplying equation 1 here this is equation 1 and this is equation number 2, and now if we one multiplying equation 1 by 2, and we obtain this 30 this is 30 is equal to 2A plus 4D, naming this equation number 3, and once subtracting equation 3 from 2 we obtain minus 5 is equal to 5D, and this implies D is equal to minus 1. So from equation 2 here we get 15 is equal to A plus 2 times minus 1, and it implies 15 is equal to A minus 2, and it implies A is equal to 17. And the 10th term A10 this is equal to A plus 10 minus 1 times D, and it implies A10 this is equal to 17 plus 9 into minus 1, and it implies A10 is equal to 17 minus 9, that is equal to 8. Okay, so the 10th term of this AP is equal to 17 minus 9, that is equal to 8. And for fifth one, we have given that the value of D is equal to 5 and the S9 is equal to 75, and here we need to find the first term A. Okay, so we know that Sn this is equal to n by 2 times 2A plus n minus 1 times D. Okay, and S9 is equal to n9 by 2 times 2A plus 9 minus 1 times 5. Okay, and it implies 75 this is equal to 9 by 2 times 2A plus 40, and we simplify this, then ultimately we get 3A is equal to 25 minus 60, that is equal to 3A is equal to minus 35, that is equal to A is equal to minus 35 by 3. Okay, the first term A is equal to minus 35 by 3, and the nth term An is equal to A plus n minus 1 times D, and now A9 this is equal to A plus 9 minus 1 times 5, that is equal to minus 35 by 3 plus 8 times 5, and this is equal to minus 25 minus 35 by 3 plus 40, and this is equal to minus 35 plus 120 by 3, this is equal to 85 by 3. Okay, so the ninth term of this AP is equal to 85 by 3. So I stop here this lecture. Thank you very much to all of you.